Hello everyone, let's have a look at the area today. We're going to be looking at rectangles specifically, not so much rectilinear shapes, so I'd like to try this starter. How many possible rectangles can you draw that have an area of 24 squares? Remember, I'm saying rectangles, not rectilinear shapes, so you can't just take one off and pop it in the end in different places. Try this, make sure you draw it out, and then let's have a look. I can't possibly go through all of them because there's loads, but probably what some of you notice is if you halve the number of groups on one side and you double the number of squares in another group, you get another similar rectangle. And you can do this lots of different ways because all you're doing is you're finding the factor pairs. So you can find things like 1 times 24, 2 times 12, and if you're clever, if you're careful, you can actually just go on all the way because there's an infinite amount. You can end up having half a square times 48, and then a quarter of a square times 96. Obviously this would be very difficult to draw, but it would be possible to do a rectangle that gets longer and longer and thinner and thinner. Now, these are some of the problems I'm going to want you to do. This one we're going to do together, then it's going to be your turn for an independent task. Disaster is struck with this one. Even though some of the squares are still hidden, can I still work out the area of these shapes? Well, I think so. If I look carefully, I can see that I've got 1, 2, 3, 4, 5, 6, 7, and just under here, because I can see the line here, I know it's going to be 8. So it'd be 8 times 1, that's 8 squares altogether, isn't there? How about this one? This is a rectilinear shape, so is this one, rather than a rectangle. But if I go back to my strategy from the other day, I can split it up into two sections. So I've got this one here, which can be 1, 2, 3, 4. I've got a square on the end here, so I'm going to have 4. Let me write that one on here. Well, it's going to go there. And then over here I've got 1, 2, 3, 4. How many times? Well, it's easy to see it down here. I've got 1, 2, 3. So 1, 2, 3. I'm losing myself here. 1, 2, 3, 4, 5, 6, 7. So I've got 4 times 7, that's 28. Oh, not my best drawing. Let me try and fix that up a bit. Then if I've got 28 plus 4, that equals 32 squares. Okay, excellent. Now, what about this? Excuse me, I know my voice might sound a bit strange, a bit sniffly today. Well, I can split this a couple of ways. I'm going to do it this way, although you could split it the other way. I think that then I've got 1, 2, 3, 4. I've got that times 3, that's going to be 12. And then over here, quite difficult to see, but I've got 1, 2, 3, 4, 5. And how many times have I got it? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be 45. Add them together, I would get 57. Not even a real group. Nice and straightforward. Okay. That's it for our shared one. Now it's your turn. I want you to do this one. You can pause the video, but also I've uploaded this sheet to Powerful Mesh, so you can have a look there if you want to get a higher quality one. Once you've done it, come back to the video. And then what we're going to do is we're going to look at the area of rectangles, but with units of measurement this time. So very similar. What I've done is I've got these rectangles, and each of these squares is 1 centimeter. So I've got 10 squares, and each of them is 1 centimeter squared. That means I've got rectangles with an area of 10 centimeters squared. And just like before, I've changed them up, but they're the same thing. Now, how can I use this to calculate the area? Well, it's because 1 is 2 times 5 and 1 is 1 times 10. 2 times 5 is 10, 1 times 10 is 10. And they show that 2 times 5 is 10 centimeters squared, but also there are 10 centimeter squares in each rectangle. Just like before, we kept the same number of squares in the rectangle. Now, again, it's going to be your turn for this one. I want you to get a paper, a ruler, or some other measuring tool. You could use a measuring tape if you don't have a ruler, and measure out 10 centimeters squared in a rectangle, like the ones on the right here. So you want to try one which is like 2 times 5 or 1 times 10. Mark them into 1 centimeter chunks like this, so that then you can cut up the rectangle and rearrange it. What other options can you find there to make rectangles? What do you notice? This is very much like the one we did before, but I want you to do this practically so you can really explore what that looks like. Now when you're done with that, here's the final independent task of the day. The first one, a square is 1 meter squared. How many centimeters squared did it? Work that one out and take care, because it's not as easy as it seems. Remember that 1 meter is 100 centimeters. So this is going to be 100 centimeters on one side and 100 centimeters on the other. then give these ones a go. I'd like you to draw these out if possible. Use a pencil and a ruler to try and solve them. You don't have to draw them the exact size for things like this. You can draw them not to scale. But if you don't do it to scale, then I want you to label the sides like they've done here with how long it's supposed to be. Good luck, and let me know how you get on.